take care of it. And yeah. So here we go. First thing I want you to do is actually, for 8-2, I want you to do the warm-up problem, which is write an explicit formula, calculate the 25th term, which is just using that explicit formula. Then I want you to write it in sigma notation. The first 25 terms is a hint about how to write that in sigma notation. And then you're going to calculate the sum of the first 25 terms. Realize for letter D, letter B is very helpful. So try that out. I'm going to give you about 4 minutes. We're going to see where you end up. All right, this is our explicit formula, right? Explicit formula always has an, and it always has n. So the only things that I'm filling in is my first term and my common difference. When I get to letter B, I calculate the 25th term, so I'm looking for a sub 25. So I got 9 plus 4. I put 25 in here, not 6. And I believe that's 105. So we get that. Now, we do want to see this, okay? We want to see that plug in so that we can give you credit. Coming down here, writing this in sigma notation. You can use I, you can use N. Don't care, I'm going to use I this time. So I'm going to put I equals 1. Now it says rewrite the first 25 terms. So that's telling me what my upper bound is. That's telling me that top part. So I just put 25 up here, and then I go ahead and I drop letter A right here, and I just put 9 plus 4 and n minus 1, because this equation right here represents my series. Okay? So that's how I can do that. And the 1 in the 25 is saying start at my first term and go all the way to the 25th term. So that's what's going on there. Now for letter D, I calculate the sum, and our sum formula, remember, is A1 plus AN, and then N divided by 2. But realize, when I'm saying A1, it is simply saying whatever that number is. And in this case, it's 1, so it matches up, and that's very common. So I'm going to plug 9 in. Plus, what's my 25th term? 105. Now, we kind of structure your test like this. Like, we want you to show us you know what the heck you're doing, but we also don't need you to do the same calculation 10 times to show us that. So when you're doing this work, look at your work. Understand, what is it telling me? Sometimes I can use something like, for example, from B, I can use down here and save myself some time. If you've already done the work, I don't need to see it again. And if I look at A, notice A basically went right into C. So they're all kind of connected here. But so I get 9 plus 105, and then I get 25 divided by 2. And so I get 1,425. Question? So that's kind of a summary of yesterday, right? That's everything we did yesterday. We did, can you write an explicit equation? Can you calculate a term, which in this case we did the 25th term? Can we write something in sigma notation? And understand that if we write something in sigma notation, I actually don't have to calculate the sum of the first 25 terms. I could actually just give you this and nothing else, and it would be telling you the same thing. And then can I use that, and can I use the summation formula to find the sum of those terms? So as long as we understand that, or we have a beginning of an understanding of that, you're in a good place, okay? But so there's really 4 things you learned yesterday, or I should say reviewed yesterday, because we did do that in chapter 1 way long ago. So I don't expect you to see it and be like, yes, we learned that, I have everything perfect, but now we should be getting close. So is there any questions here that can be addressed? Okay, shifting gears. So this one is all about addition. To get to my next term, I go plus 4, plus 4, plus 4, and I do that over and over again. Now we are going to shift to, what do you think we're going to shift to? Yeah, we're going to multiply. So now, when I look at these numbers, I got 3, 6, 12, 24. What's my multiplier? 2. Yeah, so now we're changing kind of what our formula looks like. So I still have an explicit formula, but now it looks like this, because it is a geometric sequence. So this is kind of a nice little math thing that they do. Whenever I wrote anything yesterday for arithmetic, I wrote AN or something like that. What do you think the A stands for? Yeah. What do you think the G stands for? Geometric. So there's kind of hints that are sometimes sprinkled within a problem. So GN, what do you think that is? What is AN? Last term. So GN is the last term. G1, first term. Yeah. R, I will tell you, and I'm not going to write down, it's the same for both of them, so we don't even need to write it down. This is your common ratio. It's basically just your multiplier. Okay? If you want to write multiplier right next to that, that's fine. So letter A, write an explicit equation. It follows the same rules that it did yesterday. I'm going to have Gn just like I had An. I'm going to write down what my first term is. So that actually doesn't change at all. So in this case, it's going to be 3. And then my multiplier. You already told me my multiplier is 2, so R is 2. And then I'm going to have n minus 1. Notice that I wrote it up there. N minus 1 is an exponent. You need to write it as an exponent. If you don't write it as an exponent, it's not correct. And the reason it's not correct is because now it changes and it's like a mix of the two. And it's not either, actually. So you need to make sure you write it up top so that when you type it in your calculator and when you would apply it, it's actually giving you what you want it to give you. So that's our explicit. Very similar, again, to the arithmetic. Calculating the 12th term, we're going to do that. So I'm going to say g of 12. I'll scroll this up a little bit. And so I get 3 times 2, and then I get 12 minus 1 up here. Now, yesterday I said you can go 12 minus 1, or you could do just 11. Today I'm going to tell you, just type in 11. Okay? Because if I don't put parentheses there and I type in 12 minus 1, it gets all sorts of messed up in your calculator. So to type it in, just go 3 times 2 to the 11th power. Folks, you never put 6. You cannot combine those. Order of operation says we always go parentheses, got none of those, and then exponents. So it's 2 to the 11th, and then times 3. And so g to the 12 gives you 6,144. Perfect. So 6,144. Now, this chapter is very formula heavy and it's very calculator heavy. So please make sure you know how to use your calculator, make sure you know how to use those formulas. Any questions on this? Go to the next problem. So details. All right, details are going to matter here quite a bit. So when I write this out, you can tell me what's my first term? 64, nice and easy. What am I multiplying by? 1/2. That's good. So a geometric sequence, there's no division. We never divide. Okay? So some of you might have been tempted to say divide by 2, and I get that. Okay, it's doing something that's kind of equivalent. But we are always going to use the fraction because we are always going to multiply. We never divide in a geometric sequence. So I'm going to have 1/2 and then n minus 1. Now, what am I going to type in my calculator? If it's 1/2, I'm going to type in 0.5 because that's not an approximation, it's an exact amount. But if this was 1/3 for an example, I'm typing that fraction in. And so if you want to get in a good practice of that, when you type this in, you can type in 64, parentheses, 1 divided by 3, close parenthesis, your caret on top. If I'm looking at the 10th term, I'm going 10 minus 1, so I'm raising that to the 9th power. And when you do that, oh, I put 3 there. Meant to. Started talking about 3 and just went with it. Meh. Do you know how to use your calculator to give you a decimal to a fraction? Do you know how to get fractions on your calculators? No, actually. So you're hit second after you get that answer of 0.125, and then you're hit PRB, and that gives you a fraction to decimal conversion. Did you get it?
Oh, I did it. I did it opposite.
All right. So we like fractions here. And, you know, if you give me this answer, this is not rounded. However, a lot of the answers you're going to give will be rounded. And so if you round an answer, we're not actually going to accept it as the full answer. We're going to take off half a point on every answer that you round. So it is in your best interest to do fractions whenever possible. Okay? We'll see a couple more examples as we go, but you really want to try to get used to doing the fraction as your answer. We're going to calculate the 15th term, and so I get 64 here. 1/2, and this is to the 14, right? Because I'm going 15 minus 1. Wendell, did you type this one in? What did you get?
It's like weird on my calculator.
Okay, that's fine.
You want to look in?
No, I know what it is. I just don't know like everything, but I know what it is.
Like times 10.
Yeah. You're in scientific notation, which is fine. So, you know, if you, I can help you with that. If you type this in, you get 0.003900625. You think that's right? Dead on? It could be. I actually don't have any idea. But if I typed it in a different calculator, I wouldn't be surprised if it gave me a longer decimal. If I typed it in a computer, it gave me an even longer one. We don't want to approximate. So let's all do that. Hit second, and then PRB, and then enter. And that gives me exactly 1/256. So on this one, that's my answer. Your calculator eventually has to round. So even if it isn't this problem, it will at some point. So 1/256 is going to be your answer. And that's why I say, just try to do fractions. Because if you can do a fraction for every answer, you don't have to think about, am I rounding, am I not rounding, is it exact, is it not exact? It's just what it is. Okay? Now, again, if you give me 0.5, I understand that 0.5 and 1/2 are the same. It's an exact answer, no rounding. That's okay. Questions there? We got two other things to look at. You can cross off C on this one. So I'm going to write this explicit. I want you to write it, if you can. The signs are a little tricky. Just think about the numbers that are going into it, though. So what's your first term? What would you be multiplying to get the next one? No. Now it should be there. So 51 divided by 50.
Oh yeah, I did. Makes sense.
Yep. Alright, so the eighth term, I get negative 500. Make sure you don't put like the subtracting sign there. And then I get negative 1/2. And then I get 8 minus 1. And when I calculate that, I don't remember the number off the top of my head, so I'll just type it in. You do end up with 3.90625, which I'm going to change to 3 and 29/30 seconds. This is the answer I truly want to see. Questions? If you're not getting it, I will help you on the next one, okay? So, oh, you're good. All right. So I'll be walking around on the next one. Is there questions on this one, though, before I slide on to the next? I want to point one thing out about this. If you think about these terms, my first term is negative 500. That's way the heck down there. I'm going to say this is 0, okay? Just the height. Then it jumps. My next term is 250. So it's half the distance. But then it jumps back over, and it's doing this. Is it ever going to hit 0? No. Because no matter what the distance is, I can always cut that distance in half. And I can cut that distance in half again. Now, in the real world, can I necessarily cut something insanely smaller and smaller and smaller? Not necessarily. But mathematically we can. And so it's getting into a hypothetical realm, which is kind of interesting. Moving on to your last one, number 4. I want you to try this, and I want you to only calculate the 6th term. So try this out. I'll give you about 2 minutes, and like I said, I'll walk around. So if you did have questions about the calculation, I will try to help you with that.
How do I convert that into that?
Do that. And that is 100% okay. Oh, okay. I actually like this answer better. It's just, this is the extraction. So if I do that, actually my answer, yeah, I don't have this. I'm going to do that secondary. These other calculators just make that one though. What do you say? Over the night.
Wait, that makes so much more sense.
It won't let you. Because it doesn't know how to. Because this is repeating. And so when it repeats over and over and over again, your calculator doesn't actually know how to do that. We can do that. Okay. That's actually where you're smarter than your calculator. You can't do it yet. After 8, 4, you can do it. But if this is the case, then I'll just let you write that down.
Thank you, man.
Oh my god.
Thank you so much.
Yeah, you're not.
Okay, so we're not gonna be doing the 19 and like a
Oh, you still will.
Okay. Okay.
Okay, folks, this is what we got. We got g of n equals 1,000 times 9 over 10. I do want to see the fraction in there. That is a place I always want to see the fraction, my multiplier. Then I got n minus 1. And when I calculate this, what do I get for b? What do we get?
590,
Awesome. And that is good. Now, if you were brave enough to calculate letter C, and you hit fraction to decimal, your calculator does not actually change it from a fraction or from a decimal to a fraction. That's because your calculator doesn't always know how to. Okay? So, for our class, if you try it and it doesn't work, show it to me, especially if it's the test. And if I go, yeah, that's okay, you can write it down. Because there comes a point when we can either teach you way more than what you need, and then you could do that, or we can just let it go. So we kind of let that go. But eventually you will actually be able to do something your calculator cannot. And you learn about that shortly. So that is our lesson for today. There's an answer key posted on the back wall. I would like for you to get 2 of those problems done, not the warm-up. Okay, so 2 of the problems on your homework done that are not the warm-up, so you can check it and get help if you need it.
Oh, good.